Alright, hi and welcome ladies and gentlemen. Today we are talking about Quicksort. Quicksort is a really basic sorting algorithm that has a really nice recursive variant and is based on the divide and conquer approach, where bigger problems get split into smaller problems and then the smaller problems will be solved. It has a few nice features. One is that it has an in-place sorting algorithm, or that it is an in-place sorting algorithm, meaning that it doesn't need more space for sorting data. And it has an average time for sorting of n log n and a worst time of n squared. But it's really hard to get really this worst time. Alright, so there are a few steps in Quicksort, and it is at first to determine a pivot element. Well, a pivot element is basically an element that we choose randomly, which is proven to be the best approach for Quicksort. It is basically one element of our list in our data array. And then we do a few swap operations, and based on our pivot element we move some pieces or some items in our data array to the left side, and even these that are smaller than our pivot element, and all others we put on the right side. And then we go with Quicksort again over the left and the right side separately and sort these. That is the divide and conquer approach. And so in the end we have a singleton list if we do that over and over again, and singleton lists are naturally sorted by themselves. And there we also see the worst case, and that is if there is always like just one list beside our pivot element and the other list is empty. Alright, let's go through an example. Well, here we have the initial list 75, 38, 42, 1 and 10. And in our first step we have to find the pivot element. I took randomly the 38 here. Alright, and then in the next step we have to compare our items with our pivot element. Here we have 75 is bigger than 38, so we have to put it on the right side after our pivot element. In the next step we compare our 42 with 38, and 38 is smaller than 42, and because of that we put it also on the right side in the right list of the pivot element. In the next step we compare the 1 with the 38, and the 1 is smaller, so it has to go to the left side of the pivot element. And we do the same with the 10, and then it goes also to the left side. Alright, now we have our two separate lists. The 1 and the 10 is our left list, and the 75 and the 42 is our right list. So we go over them with our Quicksort algorithm again. So we have to choose our pivot element, that is here the 10. So we compare the 1 with the 10. The 1 is smaller, so it stays in the left list. And there is no right list, it is empty, there's no other element to compare it. Alright, and in the next step we do the same for the right list. We choose a pivot element, that is here 42, and then we compare the 75 with the 42. It is bigger, so it has to go to the right side of the pivot element. And then we just take down our pivot element, and so we have it now sorted. And in the last step we have just single lists left that we could sort, and that is the 1 and the 75. And so we are here at the end. Alright, let's have a look at the recursion tree of the Quicksort algorithm. Okay, we have again our initial list here with 75, 38, 42, 1 and 10. And in the first step we took the pivot element 38, so we write it down. Then we have to go through and find our left and right list. And so we had the left list is the 1 and the 10, and our right list is the 75 and the 42. Alright, over these lists we have to go again then with Quicksort. So we choose another pivot element and have the left list 1 because it is smaller than 10, and the right list is empty. So we have just single lists or empty lists left. So we are at the end there for this particular node in the tree. So we can put our result together. And that is kind of interesting that we can write it like this, because the result is left list, then comes our pivot element, and then comes our right list. But since all elements in the left list are smaller or equal to the pivot element, and that is sorted, so we can write it on the left. And the same holds for the right. In the right list, every element is bigger than our pivot element, so we can write it after it. Okay, so we are there, done with our recursion in this node, so we can go to the next node in our stack. Well, we have to choose a pivot element again, and then we build our left and right list. The left list here is empty because 75 is bigger than 42, and in our right list is 75. In the next step we build our result again. So we have the left list, then we append our pivot element, and in the end we append our right list. Alright, so we are also done with this node, so we can put it together to get the final result. We go one step up in our stack again, and there we put the result together. And there it is also again the left list, which is sorted by now, and all elements are smaller than our pivot element. Then comes our pivot element, and then comes our right list. Alright, so let's go over and implement it in Python. Therefore, I do a new file called quicksort.py, and I create a class here called Quicksort. And there I create a method called sort, and that gets by Python the self attribute, and it gets some data array. Let's make some comments here too, some documentation. Data is let's say array of numeric items. Alright, so in the first step we have to find a pivot element, and to do that we choose a random index of our data array. So we say our pivot index is and there we take a random element. So therefore there Python has a built-in method or built-in library called random. So we import it here, and then we can go down and say random.randint, which gives us a random int in a certain range, and we go from 0 because lists start at 0, and then we take the length of our data array, and that should be fine like that. Okay, in the next part, we have to go through all our elements and create the several right and left lists. So we create them first. Here we make them, or we initialize them as empty lists, and then we go through our elements in our data array. So we have a counter variable I, and we have to go through range gives us all the numbers in the given range from 0 to there. So we iterate with a for loop through each of the numbers, and there we need the length of our data array. And that should be fine for now. Alright, the first step we should think about is what happens if E is equal to our index of the pivot element. Then we don't need to do anything, so we can keep going. So if E is equal to pivot, then we say continue. Alright, else what happens next? Now we check if data I is smaller or equal to our data of the pivot element. So, if it is smaller, it belongs to the left list. So we can attach it there. So we say left list dot append data I. And if not, it is bigger, so it goes to the right list. Else right dot append data I. Alright, so good so far. That is a great start. So what we need to do now is we have to put together our results. We have our lists. So we do a new data array result, and then we have to call on the left and right list our quicksort algorithm again. So we say self.sort, and we sort now our left, and we have to do that also with our right side. Alright, and then we return our data array, our result. Alright, so how do we get the stuff now in our result? Yeah, that's our return, or that is what we return from our function. So we write the result dot, here we need to do extend because we get a list, and we do the same for the right side. Alright, and then we forgot one little thing, and that is in the middle we have to append our data pivot. So with that we call our sort algorithm on the left and the right list, and we append it to the result as well as the pivot element. There's one little thing we still have to do, and that is find an exit condition for our recursive algorithm. And there we can say if we just have a singleton list or an empty list left, then we can return. So we can say if the length of our data is smaller or equal to 1, then we also return our data, because singleton lists are obvious. Alright, so that should be it. If I have a look now, we can now try it out. name equals to name. Then at first we instantiate our class, and that is sorter is Quicksort. And then we need a data array, and we call data, and we put just some random numbers. And 20. Alright, so now we can call the sort method in our sorter with our data array. And since we just want to check if it works fine, we can simply put it out to the console. Alright, let's run it and see if it works. Oops, we have a list index error here. Index out of range in 21. So if we have a look here, then we need to go one less for our I. Alright, that should solve it, I think. And there we go. We have -1, 17, 24, 23 is missing for some reason. Alright, I go and have a look and check out what went wrong, and then I come back in a second. Alright, welcome back. I found the mistake, and the problem was that random here includes the outer interval, or the limit of the interval, so I have to decrease that by 1. This part here was actually okay to say range name data, because that gives, or that doesn't include the outer interval. Alright, so if we check that out now and run it again, here I have the numbers, then that works fine, and as expected, -1, 17, 23, 23, 24, 42, 71, 99, and we can also maybe add another 2 here, and let's say the 88 here. So, and if we run it now, we should be fine, and that looks great. Alright, ladies and gentlemen, that was it for this video. Thanks for watching. You can like the video if it helped you, and you can subscribe to my channel if you want to get news when I upload new videos. So thanks for your support, and we see each other the next time. Have a great day. Bye.